Swayam Prabha, free DTH channel for education.
Hi students, in this video lecture and in the upcoming subsequent video lecture, we'll be taking a look at some of the questions that students commonly ask, particularly when they are beginning their journey in medical imaging. In this video lecture, we are going to answer two questions. First one, where can I find some interesting medical imaging challenges and competitions so that I could start working on them? And the second question is, where can I find medical imaging data so that I don't have to look for acquiring the data, but would rather right away start working on that particular data? Those are the two things that we will take a look at in this current presentation. There is a web page called grandchallenge.org. I'll put the link to it in the description section also. You could go through it, and of course in the slides as well. This is the platform where they collect and put all the information about the challenges together. Interesting challenges happen every year along with the MICAI conference. Medical image computing and computer assisted intervention. So I was referring to it in the very first video lecture. Some of them are right away hosted here on this web page. In addition to MICAI, even ISBA every year conducts some challenges. ISBA is IEEE International Symposium on Biomedical Imaging. Let me quickly take you through this website. Here is the website I was referring to, grandchallenge.org. It has various sections. Let us first quickly go through them. One part is manage your data, where you upload your data and then control who has access to it, and view data with our globally available browser-based workstations. And then try and expect annotations, where you could upload your ground truth. This is more of like a training. You ask them to annotate those who want to learn, and then you compare it with the ground truth labels and give them the score. And then gather annotations. You might not be having ground truth, that's what you want to generate. For this purpose also you upload your data here. It has online browser as well as some labeling tools, so the annotators can log in here and then make the annotations. For a given competition or a challenge, they could upload their results, and it has a leaderboard individually for each challenge, and you could see there the results. On the other side, you could deploy your algorithm into this web page, and then people can upload their data and see how good the results are from that particular algorithm. And it also gives you references to various certified products in the area of medical imaging. And then you see here interesting statistics. There are around 45,000 registered users for this. There are currently 259 challenges going on. Most of these challenges usually provide you the training data, testing data, and also in some cases hidden test data, and then your algorithms could get validated there. And around 40 algorithms where you upload your data and see how a particular algorithm works on your data. It also gives you other interesting statistics as well. First thing I usually look at is how many users, participants are there from India. Okay, 2,331. Not bad. Out of total users of 45,107 as of now. And it also tells you which is the hot competition that's going on right now. That is, for example, Drive, Refugee, and then you could go through those challenges there. So let me now quickly take you through this challenges part also. You later go through it in more detail, but this is where you find a lot of challenges here going on. In the rest of this video lecture, let's take a look at a couple of challenges that are either hosted here or linked here. The first one is auto implant challenge. Now, this challenge has been hosted in conjunction with this year's MICAI 2020 challenge. You could already figure out from that screenshot itself that this aims at designing a cranial implant for the skull. There is a surgical process referred to as cranioplasty, where defects in the skull will be replaced or repaired using the cranial implants. And these defects could come from different reasons. For example, if there is any tumor in the brain that needs to be treated or removed, so in those cases there could be a damage depending on the location of the tumor to the skull. Or this could also be due to an injury where a person met with an accident and his head got injured. Depending on the region where he got injured, there could be this defect. And now this challenge aims at designing an implant that fits precisely against the borders of the skull. This whole process of designing in fact involves quite a lot of steps. For example, you would start with the 3D scan of the head, and then from that one can figure out the regions where an implant needs to be designed. Again, to this end there are more details. For example, the 3D segmentation of the skull, you will go towards the 3D mesh of the skull, and from there are different ways you could design this implant. For example, one could design this implant by starting with the skull of the current patient, and then coming up with a design or learning how the whole skull would look like, and when you subtract that whole skull from the existing skull, you would be able to design the implant. Another way is directly designing the implant instead of looking at the holistic continuity of the skull. As a part of this challenge, they have provided a training data set of 100 CT images and a testing data set of 100 CT images. Each of these images are having 512 by 512 pixels in the axial direction, and there are slices in the Z direction. In order to have a proper ground truth, they started with the head scans of people with normal head without any injuries, and then from that they artificially injected or created some holes or damages in that. There are three inputs that have been given for each of these CT images. One, the complete skull. The second one, the skull where artificially certain damages have been injected, which you know precisely, so you also then know what is the shape or the 3D design of the implant as well. These data sets are publicly available now. You could register, download, and give it a try. Another interesting challenge that has been mentioned in this grandchallenges.org that I would like to quickly mention is detection of abnormalities in the knee MRI images. This challenge is hosted by Stanford Machine Learning Group. I guess this has been hosted in 2018, and of course this is continuing. Currently this is the largest publicly available data set with labels for MR knee images. It has, for example, 1370 MR examinations. Each of these examinations will have 256 by 256 pixel resolution in the axial slices, and the number of slices in the Z direction would be varying from 17 to 61 depending on that particular patient, and on an average you have 30 slices there. The clinical experts have labeled certain types of abnormalities on these scans. For example, anterior cruciate ligament tear, and another abnormality marked is a meniscus tear, and of course a few other things are bunched under just as an abnormality, and a patient can in fact have more than one abnormality as well. So you can download this data set, the training data set and testing data set. There is a hidden testing data set as well. You come up with your own algorithm, you submit your code into their GitHub page in a format that has been specified there, and who knows, you could be also there on that leaderboard if your method is performing well. I will stop the lecturing part for this recording with that, and here comes your first assignment. The assignment is that go through various challenges that have been hosted in the grandchallenges.org, and then pick one that you find interesting and make a 10 minutes video on that. The 10 minutes video can have these components of a bit of background, including some clinical background, then the motivation for this challenge, what would be the impact of this challenge, and then about data sets. Optionally, you could also mention about the type of methods that are giving you the best results and any other thoughts that you would like to share here. And our TA will shortly share with you an Excel sheet where you specify the details of the challenge that you have picked up so that no two students are picking the same challenge. That's all for now. See you in the next video lecture. Thanks for watching. Bye. Take care.